Okay, so from now on, we're gonna write it using limit statements, okay? So when you see these, don't, and we're gonna do more with limits, but we're gonna use our limit statements to write all our end behaviors now. Okay, so get used to that. That's what's on the AP test. Okay, so here we go. Okay, so we're gonna describe the end behavior verbally and using limit notation, okay? So here, both of these have arrows on both ends, okay? So we're gonna write what's happening on the left-hand side of this graph. So what's happening here as X, we're now gonna decreases without, oh, I wrote this, typed this out, without bound. Okay, as X goes decreasing, what's happening to your function? It's going up, 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 right? On the left-hand side, so it's what? Going towards infinity, right? It's the same thing. I forgot I typed it. As X values decrease without bound, Y values increase without bound. Decreasing means getting smaller, so negative infinity is smaller. Y values are going, on the left side, it's going up, so they're increasing without bound. Okay. So how do I write this with the limit notation, right? So just write what? Limit as X goes towards, going to the left, the X values are going towards what? Negative infinity. And my function, they didn't give us a letter, so we just write function equals, it's going up, infinity. Okay. What's happening on the right-hand side of my graph? As I move towards the right, my graph is going what? Down. So how do I write that verbally? As X values go up or increase without bound, Y values decrease without bound. And what's the limit statement for that? Well, it's the same as the top one, but what do we change? The X goes towards positive infinity, right? And your answer is going down, so your answer should be negative infinity. So you guys go ahead and do the right graph. Both of these have arrows. They have to have arrows to have an end behavior. Okay, so you can split it up with your partner if you want. So you do this half and on this half. Up to you. Okay, so go ahead and work on the right-hand side. when you're going left side, right? The left side, the beginning statement should what? Be the same. If I'm moving left, I'm getting smaller and smaller, right? -1, -2. So that first statement should be the same. So what you're trying to tell me is what's happening. As I go left, what's happening to my graph? It's going up. Up means it's what? Increasing, right? So as x values decrease without bound, y value is what? Increase, right? So this first part of the limit statement for the left side should always be the same. This is what? As you're going left, as x goes towards this part is always the same. What do you just gotta decide? If it's going up towards infinity or down for right now, down towards negative infinity. When we have exponentials, it changes to a number. Okay, so here we go. As x values decrease without bound, y values increase because it's going up. Okay, so this part right here always stays that always the same. So in this only thing you're telling me if it's what? Increasing or decreasing, right? And our limit side for the left-hand side, this always stays the same. You're just deciding if it's going up or down. Up is a positive infinity. Okay, so same thing here. As x values increase, that tells me it's going to the right. Y values what? You got to decide if that's the only part you decide. And what's happening on this one? It's going up, so they are increasing. Okay, and the right-hand side for the limit statement, this always stays the same. You're going right, you just got to decide what the number is. And what's the number on this one? Positive infinity. Okay, now let's just review something we talked about yesterday. This first one here, is it an odd or even degree polynomial? Huh? I heard odd, what else? Even, what else? Anybody? Well, that's the two. Anybody else want to? Odd or even here? Odd, why do you say odd? Yeah, remember yesterday? It's odd degree, because why? They're going in opposite direction. Huh? Oh, okay. This one is what? Even, right? Because it's going the same direction. Okay, somebody, okay, on the first one here, does anybody tell me if the leading coefficient is positive or negative, or why? Why is it negative? It's going down in the end, right? So your leading coefficient is, how about this one? What's your leading coefficient here? Why? Up. Both of them are up, right? Okay, that's just to review there. All right, we're gonna graph these next week, so you have to know all those. And we have the little chart here. Everybody done here? Okay, next one. Sketch a polynomial function with the given end behavior. Okay, so what is my end behavior here? As x goes towards negative infinity, my function goes what? Towards negative. So this tells me what? The left side is going down, right? What does this tell me? On the right side, positive infinity, right side, my graph is going what? Down. So just draw a polynomial here. Oops, I shouldn't have a v in there. There, that's my polynomial. Does it matter what you draw in there? Okay. How about this side? This next one. On the left side, we're going what? Down, and on the right side, we are going up. Draw one of yourself. Just draw one. Left side down, right side up. You guys, you don't have to have the same one as me. Just draw one as your own. Left side down, right side. Okay. So what is this one? I just draw like this. That's fine. Okay. So what degree is that first graph? Odd or even? Even degree. Is my leading coefficient positive or negative on this one? Negative, because they're both going down. This next one, opposite direction says what? They are, it's what? Odd degree, right? Oh, that's easy to remember. And is the leading coefficient positive or negative? Positive, why? And it's up, it's trending towards up, right? So it's what? Okay. Those should be pretty easy to do, right? Okay, we ready? Yeah. Oh. Okay. So here we go. Polynomial and behavior. Okay, just to write. If I have an even degree, the ends are what? In the same direction. Okay. If I have an odd degree, ends are in opposite direction. Okay. So this just summarizes what we did on the other problems. So even degree and what? Positive leading coefficient, right? So if it's even, it's same direction, and it's positive, what are we going? Up, up, right? So a graph, this would be an even degree with a positive leading coefficient. Okay. Even degree with a negative coefficient means it's what? Going down, down? Odd degree and a positive. So when you look at positive, that's where you want to end up. That's what you're trending towards. So it's positive, I'm trending up. So the right side has to be up, the left side has to be down. Okay, it's what you want happening in the end. So it could be like that. And if your leading coefficient is negative, then you're trending downwards. So you want to end up down. So that's not. Okay. We good here? Okay, so our next ones, let's decide. You guys are gonna, I'll just do one. You guys can do the rest. Okay, what is the end behavior for the following? We're gonna write it with limit notation. Okay, so this one, what is this? Odd degree. So odd degree is what? Opposite, right? So we need opposite direction. And what is this? Positive. So what do I want to happen at the end? Goes up, right? So how do I write this with limit? The left side is what? Limit as x goes towards negative infinity, as x approaches negative infinity, of my function is going what? Down, down, down means negative infinity. Okay, that's my left side. My right side is what? Limit as x goes towards infinity of my function. What is it going? It's going up, 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 up. So it's what? Positive. That's easy, right? All right. Go ahead and work on, to split up with your partner. You can do, there's three, but you can figure, two of them are the same answers. Go ahead and work those out. Decide what you guys want to do. Are we all done with B, C, D? Those are up there. Those should be pretty easy, I think. E and D are actually the same, right? They're both negative x to the fifth. Okay, are we all there, all done with those? How about F? Can anybody tell me what the degree of F is? Huh? I can't hear. So the degree of 0 would just be a horizontal line, right? If I graph that, we're gonna have some. What's the degree on that one? How'd you get 3? Yes, because what's the difference between these? These are factored, the one we just did, right? F is factored. Are the ones up here factored? It's like your homework last night. You had an x squared problem. You made it what? X parentheses x something, right? Parentheses. So you have to multiply these out. And if I were to multiply these back out, what are you going to get? X to the third. Or what they tell you could do is you add the exponents, which are all 1. So your degree is 3. So this is what? Odd, correct? Anybody know what the leading coefficient is going to be? Is it positive or negative? Who said negative? Is that Willow? Or no, weak? Why you say negative? Yeah, so you have to look at all your x's where you're going to get the x cubed. So what would you multiply to get the x cubed? 2x times what? X, which is positive, but then what's over here? Negative x, because you're going to end up multiplying those, and that's your leading coefficient. So 2x times x is 2x squared times a negative x is going to end up being what? Negative 2x cubed. So your leading coefficient is actually negative. Okay. So what's going to happen here? It's going to be the same end behavior as that one, correct? It's the same end behavior. I'm not going to write it down. You just, okay. I'm going to make this difficult. You guys see the one I just wrote on the bottom? What's the degree on that one? Huh? So what are we multiplying? We got to get all our x's, right? So what are we multiplying here? 5x squared, right? Don't you have another x there? It's gonna be what? 5x cubed. Don't you have more x's? The highest one, what's that gonna be? 2 more, right? So what is that gonna be? 5. So you got to be careful. You can't just add the exponents on the outside. If there's something on the inside. So the degree is what? 5 here. And what's my leading coefficient going to be? Positive or negative? Positive. Positive, right? But this one here, the 3 isn't being squared. It's only the x is negative. So the leading coefficient is negative there. Okay. You got to think what's going to happen when you multiply it out. What's my biggest one going to be? Okay. I would get a different answer if I put the squared on the outside. Then your leading coefficient actually becomes positive. Okay. Because now you have negative 3x and another negative 3x, which makes it a positive. All right, we good? Okay. This one I want you guys can do on your own later for your homework, but this one here, this is like something that could be on the AP test. So I want you to read through and see if you can figure out what is the answer. Okay. My suggestion when it's saying which one is true, If in a sentence you see something is false already, just cross it out and don't bother reading it. Go at peace. When you're trying to find something that's true, you got to read all of them, correct? So my thing, you know how when I was doing it, I said, oh, that part's wrong, so just cross it out. I don't need to figure out the rest. Part's wrong, okay? So see if you guys can figure out which one is it, A, B, C, or D. Okay. Remember the shopping cart problem? Get another one today, which is the locker problem. This one's more. I really saw people be accused doing this class, and they were like, his girlfriend, I don't even. Who was it? I don't know who was it. It's a fun problem. I don't know. I have to work it out too. I'm supposed to work out beforehand. What was this weekend too? They don't give me the answers. Okay, are we ready for this one? Did we figure this one out? A, B, C, or D? D, okay, let's see here. Let's see, the sign of the leading term of F is what? Is that true or false? False, I don't even need to read the rest of it, correct? Got it? Sign of the leading term is negative, that's true. And the degree of the leading term is odd. False, I don't need to read the rest of it. Sign of the leading term is that's already false, so it should be what? B, let's just double check. Finally, it's negative. The degree is even, so it's what? Negative and even means it's going down, down. So negative infinity, negative infinity. Okay? All righty. Stop this here. All right, this is a fun